This video is part of the certification program, SABA, Spreadsheet Applications in Business Analytics. Please contact if you want to apply for the certificate program, or for more details.
Then we want to discuss about the variance, dispersion. So how do we understand the dispersion? So that is the second moment. That means how much away the data are away from the central location. Now this can be understood from this some example. Let's say suppose you have a number 1 to 100. This is one data set you have, and you have another data set which is, let's say, 1 1 100 100. So these are the four numbers you have. So 1 1 1 to 100, this is the 3-number data set, and this is 1 1 100 100 4-number data set. I want to understand which one is more dispersed. So you can see that the dispersion here will be more because you have 1 2 and then 100. But here you can see that 100 100 2 data are there, and 1 also 2 data points are there. Frequencies 2. Here the frequency all was only 1 as the frequency. Right. So what we will do is, we want to know how much is the dispersion. Here more dispersion or here more dispersion. So we have one very crude measure is called as range. So a very crude measure is called as range. So what is the range of the data? Range of the data is given as maximum minus the minimum. So you compute the maximum minus the minimum. In this data set, actually the range is same. 100 is the maximum, 1 is the minimum. So the range is 99. Here also the range is 99. However, we know that this data set will be more dispersed than probably this data set. We'll see. So the range is not a correct measure of dispersion. It just gives the maximum minus the minimum. It may not result in the correct measure. So we'll see. So we have some other metrics. One of the things that you would have seen in your college was variance. So what do we do is, when we are computing the deviation, computing the dispersion, we'll compute the average value. So we'll have the average value. So all the data we'll try to compute from the average how much distance they are from the average. This is called as deviation. So you have, let's say, suppose x1 is a number. So deviation is computed as x1 minus x bar. Now this deviation is x2 minus x bar. So in Excel, let me do some quick calculation and we'll see that what is deviation. So let's say the number is 1 1 100 100, and we'll compute the deviation. So for computation or deviation, we have to compute the average. So we can compute the average. This is the 50.5 is the average, and computation of deviation is the number minus the average. The number minus the average is the deviation. So 49.5. This is also 49.5. But please note that I am saying 49.5. But here you see the number is minus 49.5. So when I am saying the deviation, so deviation can be plus. If the number is greater than the mean, the deviation will be positive. If the number is less than the mean, then the deviation will be negative. So the deviations are negative and positive. Now one other thing, if you do, you sum the deviation. If you sum the deviation, you are not going to get anything out of it. If you sum the deviation, the sum of the deviation will always turn to be 0. Because the mean is such a way placed, it is a central. So the deviation of one number from the mean, another number from the mean, you sum it all, the deviation will come 0. So that means when we are computing the dispersion, this guy is not giving us any output. So in statistics, what do we say? This is definitely a deviation. This is definitely away from the mean. So rather than thinking this is in terms of negative, we will make it a positive number. So how we can make it as a positive number? So suppose, let's say I want to make x2 minus x bar as positive. This was negative. Okay. There are multiple ways to do. One is you can square it. What could be the another way? Let's say x2 minus x bar. You can take the modulus of it, absolute number, right? So if I take the square, so if I take the deviation square, what will happen? This is squared. Okay, so you can see the numbers are positive. This is positive, this is positive, this is positive, right? So we have an idea, okay, I can get a square out of it, I can get some deviation, okay, some positive number, and then I can sum that. Okay, so what we are doing is we are summing the square of the deviation. So we can sum the square of the deviation, right? Now this square of the deviation will not give us any, the sum of the square of the deviation may not give us any information. Okay, why? Because a number, so if I copy this, okay, in another sheet, and I make it all, I multiply by, let's say what I will do is I'll multiply this by 10, 10, 10, 10. Okay, so you can see that sum of the square deviation. So this is the sum of the deviation. Okay, we'll compute sum of square deviation here. Okay, sum of square deviation. Okay. Sum of square deviation is 9,80,100. Here the sum of square deviation was. Okay. By the way, sum of square deviation we are computing like this, but there is a formula, okay, in Excel, DEVSQ, DEVSQ, deviation square. I can just select the numbers, okay, and I can get the square of the deviation. So I don't have to make all these columns and all. So I will delete it. So in Excel we have a shortcut to compute the sum of the square deviation, that is a DEVSQ. Okay, so it is given as 9801 and here it is 980100. Right? Now you may say that, okay, this is less dispersed, this is more dispersed. Right? That is like because of the square deviation. That is like some idea we can have, right? But we will do some standardization, etc., and we can see that, okay, this deviation, only the sum of square is not useful. Okay, we have to make it, okay, per unit. Okay, so total sum of square is 9801. Okay, total 9801. But we have how many data sets are there? Okay, 4 data sets. So how much is per unit? Just 1 minute. Okay. We are interested in it is how much it is per unit. Okay, so what we'll do is we'll divide this by, okay, the number of units we have, which is like we can count manually 4. So this is the sum of square deviation average. Average of sum of square deviation. Okay. Okay. Actually, this average of sum of square deviation is what is your variance in statistics. Okay. So you are saying how much is the square of the deviation? Why we did square? Because we wanted to make it positive. It has some other aspect also, because in differentiation it can be used. Okay. So I will take the average of some square. That is, I am saying, is the variance. Okay. But you can say, okay, why have to square it? I can also take the absolute value, right? So I can take the absolute value of this. So absolute value in Excel is ABS. So for a negative absolute value, if you want to find out, okay, you have to do ABS. So, okay, what is this? Okay, an absolute value of a number without its sign. Yeah, see this. Okay. So see, we have got one absolute value. Right? So one method you have is like either you take the absolute value, okay, or you take the square to make it positive. Now when I am taking this absolute value, see this deviation was negative, summing was making it 0. But if I take the sum of this all 4, it is not going to be 0. Right? It is coming up some number. Okay. And now what I can do is I can take the average of this. So this I divide by 4. Okay. I get some number like this 49.5. Okay. This is what? This is the sum of absolute deviation divided by the number of values we have. So this is called as your mean absolute deviation. Okay. So mean absolute deviation is also a measure. Okay. However, this is not a good measure compared to average of sum of square deviation. It is not a good measure. Okay. But it has some advantage and disadvantage both. Okay. Now here, let's say suppose these numbers were all, let's say the weight of boxes. Okay. What is the unit of weight of box? Kg. Okay. What will be the unit of this deviation square? The unit of this deviation square will be kg square. So you can see that it will be kg. How you make it kg square? Okay, you can go to font, okay, and make it a superscript. Okay. Okay. Only that item you have to make a superscript. Okay. Just 1 minute. So what we can do is we can have a superscript. See this? It has become a. So if you see that, it has become kg square. Now what I want to tell you is that all of these units will be kg square. When you have taken the average of sum of square deviation, okay, so sum of square deviation, it is kg square. Average of sum of square deviation also unit will be kg square. Okay. So I say that, okay, the units are in kg, but the average of that is in kg square. Okay. It doesn't, see, we as a human being, we don't understand the power better. Okay. For us, linear measure is a better measure rather than the square measure. Okay. So in that case, the mean absolute deviation wins. Why? Because the mean absolute deviation, the unit is also kg. Okay. Because this absolute value, the deviation values are in kg. So mean absolute deviation is also in kg. Okay. So many people, like, they want to understand, okay, the mean absolute deviation, and they go with this. Okay. However, average of sum square deviation as a unit of kg square, how I can convert from kg square to kg? How we can get? What we can do is we can take the square root of kg square. If I take the square root of kg square, it will become kg, right? So if I take the square root of average of sum of square deviation, the unit will be in kg. And when I take this average square of sum of square deviation, this was nothing but the variance. If I take the root of variance, you know that it will become the standard deviation. So that is the reason that we have standard deviation. Otherwise, variance already is there. What is the need of standard deviation? Standard deviation we need so that we can bring it into the unit at which the data are there. So I can take the root of this. So you can take the root like this to the power 0.5, or you can take SQRT, okay, this number. Okay. So please note that in this case, the numbers are such that mean absolute deviation and the standard deviation is coming as the same. Okay. But if I change the number, let's say I make it 2, see this, and this I make it, let's say 50. So mean absolute deviation is different, standard deviation is different. So standard deviation is saying that there is a more dispersion. Mean absolute deviation is saying that it is less dispersion, right? So I have tried to explain like why, okay, how we got, why can't we use a sum of deviation? It will always be 0. So we have another method. We can go for absolute deviation, okay, and we can take the mean, because that is like we want to standardize it, okay, per unit. Deviation is square, we can take absolute values, it has become positive values. I can take the sum of square divided by the number per unit, it will become the variance. But this is not useful, we have to take the root of that, that is the standard deviation, right? So we have these four measures, okay, mean absolute deviation, range, variance, and the standard deviation, okay, are the measure of dispersion. Okay. Now, one thing about this variance is that, okay, statistically we found that when we compute this variance, okay, using dividing it by 4, okay, that is 4 is the number of data points that we have, okay, over a large number of this type of data set, we found that this underestimates the actual deviation, actual variance that we have. Okay. So what statisticians they say that, okay, this is called as population variance because you have taken all the numbers. Okay. But if we take this 4 minus 1, okay, the number of data set minus 1, then we get something called as sample variance. Okay. So what is sample variance? Sample variance is the sum of square deviation divided by the sample size minus 1. Okay. So please note that even if it is the population is 100, sample will be for that 100 minus 1. Sample variance, that is how we'll calculate. Right? And so standard deviation is the same. It will be the root of this. So the root of this will be your sample standard deviation, right? So this is how you will calculate like manually.
This video is part of the certification program, SABA, Spreadsheet Applications in Business Analytics. Please contact if you want to apply for the certificate program, or for more details.